Welcome, Algebra 2 students, to the homework cup video, page 509, or 509, where'd that come from? Page 105. Numbers 29 through 43. Let's jump right into this. Here's number 29. Let's graph this absolute value inequality. So as soon as you see this, you realize you have an absolute value inequality. You find the vertex first. Now remember, it's going to be V-shaped, okay? So the vertex is this point right here, okay? So with that in mind, you find the vertex by taking the inside of the absolute value, setting it equal to 0, and solve. Okay, bring the 5 over and make it a positive 5. There we go. And so now, I have the x value of the vertex. Now, to find the rest of the vertex, you simply take 5, and we talked about this. You put it here, and then you look at this absolute value equation. Whatever number is being added or subtracted out here like this is going to be the y value of your vertex. Okay, so there is no number being added here, so you could really put a 0 right here, plus 0, or a minus 0 without changing anything. So the vertex would be 5, 0. Okay, so step 1 is done just like that. Now, with your table of values, we're going to go ahead and draw one big enough for 5 points and put 5, 0 right in the middle. Now if 5 is here, let's go up. 6, 7, let's go down. 4, 3. So 7, 6, 5, 4, 3. Okay, now you can take each one of these numbers and put them in for x very quickly. For this x right here, I'll put a 7. 7 minus 5 is 2. The absolute value of 2 is 2. You can put 6 in for x. 6 minus 5 is 1. The absolute value of 1 is 1. Put a 4 in, and you will get 4 minus 5, or 4 negative 5 is negative 1. But the absolute value of negative 1 is 1. And then if you put 3 in, you will also get out 2. So lastly now, we're going to plot our points. So 1, 2, 3, 4, 5, 6, 7, 7, 2, 6, 1, 5, 0, 4, 1, 3, 2. I plot those very quickly. And there's your V-shaped graph right there. Okay, moving on to number 31. Alright. I realized right away that I have an absolute value equation. So I take the inside of the absolute value, I set it equal to 0, and I solve. Well, there's no solving to do. X equals 0. It's solved already. So my vertex has 0 for its x value. Now, do you see a number on the outside being added or subtracted? Yes, right here. So the y value of your vertex is positive 7. So there, we did it. We found the vertex. Okay, so my vertex is 0, 7 right here. Alright, I'm going to slide this down. I'll probably need some room in case the V opens upward. So there's 0, 7. So I know the V is going to go like this, or it's going to go like this, one of those two. So let's go ahead and write my table of values here. We're going to put 5 ordered pairs in here. Vertex goes in the middle. So there's 0, so go up, 1, 2, go down, negative 1, negative 2. And here we go. Put a 2 in for x right here. Absolute value of 2 is 2. 2 plus 7 is 9. Now put a 1 in for x. The absolute value of 1 is 1. 1 plus 7 is 8. Now put a negative 1 in. The absolute value of negative 1 is 1. 1 plus 7 is 8. And then put a negative 2 in. The absolute value of negative 2 is 2. And 2 plus 7 is 9. So there we go. So 0, 7, 1, 8, 2, 9, negative 1, 8, negative 2, 9. Am I going too fast on plotting these points? I hope I'm not, guys. Plotting points that's pretty much, actually 8th grade, 9th grade math, okay? 2, 9 is right over 2 and up 9. 1, 8 over 1 up 8, 0, 7 over 0, 0 right here, up 7, negative 1, 8 over negative 1 up 8, negative 2, 9 over 2 up 9, okay? So there's your V-shaped graph. Number 32. Here we go. Step 1, take the inside of the absolute value, set it equal to 0 and solve. And there we go. So I know the x value of my vertex is negative 2. Now the y value is this number out here that's being added or subtracted. This has nothing to do with it. If there would have been a negative 2 here, that has nothing to do with it, because that negative 2 is being multiplied times the absolute value. I'm looking for a number that's being added or subtracted directly to the absolute value, and that's a positive 9. So there's my vertex. And by the way, look, you'll know if you have the vertex. I mean, look, when I graphed this, 5 zeros right here, and everything fell into place, a perfect V. Right here, 0, 7 is right here. Everything else fell into place, a perfect V. So you'll know if you mess up on the vertex, okay? Okay, right in the middle is negative 2, positive 9, okay? Now let's go up. Negative 1, 0. Now let's get smaller. Let's go down. Negative 3, negative 4. And with that in mind, here we go. Alright, let's put a 0 in for x. Now let's do this very carefully. 0 plus 2 is 2. The absolute value of 2 is 2. But there's a negative on the outside. So negative 2, positive 9. That's going to give me positive 7. Let's put a negative 1 in right here. Okay? Negative 1 plus 2 is 1. The absolute value of 1 is 1, but there's a negative here, so this whole expression here is negative 1 and positive 9. That's going to give me an 8. Alright, let's take a look at putting a negative 3 in. Alright, negative 3, positive 2 is negative 1, but the absolute value of negative 1 is 1, but there's a negative on the outside, so this entire thing is negative 1, positive 9. That's going to give me a positive 8. And then lastly, we'll get a 7 here, put a negative 4 in for x. Negative 4 plus 2 is negative 2, but the absolute value of negative 2 is 2. There's a negative on the outside, so this whole thing ends up equaling negative 2. Then bring down your positive 9, that's 7. Now let's plot these points, and we'll be doing just fine, okay? My vertex, let's go ahead and start with 0, 7. So 0, 7, and then negative 1, 8, and then negative 2, 9, so negative 2, 9, and then negative 3, 8, so negative 3, 8, and then negative 4, 7, so negative 4, 7. You can see the V, and you know you have the right vertex because this point right here is negative 2, 9, which is what you're supposed to have for the vertex, okay? Alright, moving on to 35. Alright, we're going to graph an absolute value equation, so the first thing we do is we find the vertex by taking the inside of the absolute value and setting it equal to 0 and solving. 5 negative x equals 0. Bring the 5 over and make it a positive 5 or a negative 5. Don't forget to bring the negative down with the x. So negative x equals negative 5, so x equals 5. So there I have the x value of the vertex is 5. Now, is there anything being added or subtracted to the entire absolute value? Yes, this 4 is positive 4. So that's going to be my y value of my vertex. Pretty simple, okay? So I've got my vertex here. Next step is to write my table of values, large enough to hold 5 ordered pairs, and put the vertex right in the middle. Now, let's go up 4, 3, let's go down, sorry about that, let's go up 6, 7, let's go down 4, 3, alright, and here we go, where the x is right here, I'm going to put a 7, 5, negative 7 is negative 2, 5, negative 7 is negative 2, but the absolute value of negative 2 is positive 2, positive 4, so 6. Next, we put a 6 in for x. 5, negative 6 is negative 1. but the absolute value of negative 1 is positive 1, and then a positive 4, so we have a positive 5. We'll put 4 in for x. 5 negative 4 is 1. The absolute value of 1 is 1, and 1 positive 4 is 5. And then number 3. 5 negative 3 is 2, so the absolute value of 2. Well, the absolute value of 2 is 2. 2 plus 4 is 6. So let's plot the vertex first. 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. So there's the vertex. Alright, now 7, 6. Go over 7, up 6. 6, 5. Go over 6, up 5. 4, 5. Go over 4, up 5. 3, 6. Go over 3 and up 6. Perfect V shape. Okay, there we go. Moving on to number 37. Okay, we're graphing an absolute value equation. So we're going to take the inside of the absolute value, set it equal to 0, and solve. Divide both sides by 2, x equals 0. So my vertex is 0, comma. Here's a number being added or subtracted to the absolute value. So 0, comma 3. There's my vertex. So now my table of values should be drawn large enough to hold 5 ordered pairs. Right here we'll put 0, 3. Let's go up 1, 2. Let's go down negative 1, negative 2. Alright, let's put a 2 in for x right here. So 2 times 2 is 4, so we have the absolute value of 4, positive 3. Well, the absolute value of 4 is 4 plus 3, or positive 3 is 7. So we're going to put a 7 in right here. Now let's put a 1 in for x. 2 times 1 is 2, so we have the absolute value of 2. Positive 3, the absolute value of 2 is 2. Positive 3 would be 5. So when you put in a 1, you get out a 5. Now let's put a negative 1 in for x. Put a negative 1 here. 2 times negative 1 is negative 2, so the absolute value of negative 2 plus 3, or positive 3. Well, the absolute value of negative 2 is 2, and 2 positive 3 is going to give you 5. So the value will be 5. And then lastly, we will get a 7 here. Put a negative 2 in. 2 times negative 2 is negative 4, so the absolute value of negative 4, positive 3. The absolute value of negative 4 is 4. 4 plus 3 is 7. And so this point right here would be 7. So 0, 3 is the vertex. Over 2, up 7. Over 1, up 5. Negative 1, 5. Negative 2, 7. So this is one of the skinnier types of V's, but nonetheless it's still a V, and it fits perfectly. There's my vertex right there, which is this right here. Alright, number 39. Okay, we're going to graph this, so immediately we take the inside of the absolute value, and we set it equal to 0, and we solve. Okay, so there we go. Now, bring your 1 over and make it a positive 1. Divide both sides by 3, and you get 1/3. So my vertex so far is 1/3, comma. Now there's no number being added or subtracted to the absolute value, so you can really put a 0 there. Okay, so I'm going to put a 0 right here, and there's my vertex. Just that simple. Okay. So right here in the middle is 1/3, 0. Now, when you go up, you do not have to go to 1 1/3 and 2 1/3. Just go to the nearest whole number, which is 1, and then 2. Now going down, go to the next nearest whole number, 0, and then negative 1. And now we're good. Now, we're going to put a 2 in for x. 3 times 2 is 6. 6 minus 1 is 5. The absolute value of 5 is 5. Now let's put a 1 in for x. 3 times 1 is 3. 3 minus 1 is 2. And the absolute value of 2 is 2. Now you think because there's a 2 here, we're going to get a 2 here. And because there's a 5 here, we're going to get a 5 here. I mean, that's what's happened on 1, 2, 3, 4, 5. 5 problems so far. Not on this problem, students. It's not going to happen, okay? And let me tell you why. Okay? because you have a fraction here. Now if this fraction was 1/2 or -1/2, either one of those two, then these numbers, this number would match this number, and this number would match this number. But because we have a fraction right here that's not 1/2, then these numbers aren't going to match. And think about it, it makes sense. When you went from 1/3 to 1, you went up 2/3. When you went from 1/3 to 0, you went down 1/3. Now, if you don't understand what I'm saying, don't worry about it. You don't have to. I'm just trying to explain to you why sometimes this number here will not match this number here. Okay? All right. Now, here we go. Let's put 0 in for x. So 3 times 0 is 0. 0 minus 1 is -1. The absolute value of -1 is 1. So we'll have a 1 right here. Now put a -1 in for x. 3 times -1 is -3. -3, -1 is -4. The absolute value of -4 is 4. Well, Mr. Arrow, we're not going to get out of v. Oh, yes, we are. Watch carefully. 1/3 0 is my vertex, so over a third, up and down 0. There we go. Now another order pair is over 1, up 2, and then over 2, up 5. 1, 2, 3, 4, 5. Okay. Now 0, 1, so 0, 1, and then -1, 4. 1, 2, 3, 4. Now if you'll just connect those 2 points there using a straight edge, and then connect these 2 points here using a straight edge, you get a perfect v once again. It's perfect, guys. That doesn't matter. Over here, if this number's not matching this number, it still gives you a v, a perfect v. Alright, okay, number 41, then number 43, and we're finished, okay? Alright, now, we're going to graph this absolute value equation. So we're going to take the inside of the absolute value, set it equal to 0, and solve. So we'll take 2x plus 1, set it equal to 0 and solve. Bring the 1 over, make it a -1. Now divide both sides by 2, and you'll get -1/2. So the vertex so far, students, is -1/2. Now, is there a number being added or subtracted out here at the end? No. So we'll put a 0 for the vertex. So simple enough. There we go. So I'm going to draw a table of values that holds 5 ordered pairs. And right in the middle, I'm going to put -1/2, 0. Now let's go up from -1/2, the next whole number. Think of a number line. Here's -1/2. Going to the right, the next number would be 0 and then 1. Going to the left, the next number would be -1 and then -2. Alright, and so here we go. Let's put a 1 in for x right here. Let's get us some space here to do a little bit of work. 2 times 1 is 2 plus 1 is 3, so I have -4, absolute value 3. Well, the absolute value of 3 is 3, and 3 times -4 is -12. Alright, now let's put in 0 for x. 2 times 0 is 0, plus 1 is 1, so we have -4, absolute value of 1. The absolute value of 1 is 1 times -4 is -4. Alright, now let's go ahead and try, and I think that's a mistake. No, that's right. Now let's put -1 in for x. So 2 times -1 is -2. -2 positive 1 is -1. So I have -4 times the absolute value of -1. However, the absolute value of -1 is 1. 1 times -4 is -4. Remember how I told you on the last problem, if you have a fraction here that's 1/2 or -1/2, these numbers will match, okay? The only time this number won't match this number and this number won't match this number is when you have a fraction here that's not 1/2 or not -1/2. Okay, now we're going to put -2 in for x. 2 times -2 is -4. -4 plus 1 is -3. So -4, absolute value of -3. The absolute value of -3 is 3. 3 times -4 is -12. Let's plot our points. -1/2, 0, so right here. And then we'll have to get some extra points here, it looks like. Going down. Alright, 1, negative 12, 0, negative 4, negative 1, negative 4, negative 2, negative 12. This is called an extremely skinny absolute value graph. There we go. So still V-shaped, guys, and the vertex is still right here. Alright, number 43, and we're finally finished. Let's take the inside of the absolute value right here. Let's set that equal to 0, and let's solve, okay? 9, negative 2x equals 0. Bring the 9 over and make it a negative 9. Divide both sides by negative 2, and you will get 4.5. A negative over a negative is positive. 9 over 2 is 4.5. So far the vertex is 4.5, comma, then here's the number that's being added or subtracted to the absolute value. So 3. So there's your vertex. Now I would like to make one correction. I really knew what I was saying. I just didn't explain it very well when I mentioned to you that the top and bottom numbers are going to match in a table of values. If the middle is 1/2, I was saying any fraction that's 1/2. So you have 4.5 here. But notice the fraction part is still 1/2. So this number will still match this number. This number will still match this number, okay? So if it's 1/2 or 4.5, if the idea there is if you have a 1/2 here, you're gonna go up the same distance you're gonna go down because you're right in the middle here, okay? So you will get matching numbers. Alright, so there's my vertex. So 4.5 going up would be 5 and then 6, correct? Think of a number line. Here's 4.5. The next number up is 5, then 6, not going this way. The next number going down is 4, and then 3. So there we go. Let's quickly substitute these in and we'll see how we do here. Okay, let's put a 6 in for x. So 2 times 6. Be really careful. So negative 2. Absolute value. Negative 2 times 6 is negative 12. So 9 minus 12, or 9 negative 12 is negative 3. And then a positive 3. But hold on. The absolute value of positive 3 is 3. Negative 2 times 3 is negative 6. Positive 3. Negative 3. Let's try a couple more of these so you can practice. Let's put 5 in. So where x is, I'm going to put 5. Okay? So I have a negative 2 right here. Then my absolute value. Let's simplify this. Negative 2 times 5 is negative 10. So you have 9 negative 10. That's negative 1. Bring down your positive 3. Now, we know the absolute value of negative 1 is positive 1. These are multiplying. Negative 2 times 1 is negative 2, positive 3. That's going to give you 1. Alright, now let's substitute 4 in for x. And we should get out what? If there's a 1 here, there should be a 1 here. So I'm going to put a 4 right here. And let's see what happens. Negative 2 times 4 is negative 8. 9 minus 8, or 9 negative 8 is 1. Positive 3. The absolute value of 1 is still 1. Negative 2 times 1 is negative 2. Positive 3. And you get a 1. And then for the very last number, you should get there's a negative 3. We should get a negative 3 here. Let's put a 3 in for x and see what happens, okay? So here's my negative 2, bring it down, then my absolute value. Let's simplify all this. Negative 2 times 3 is negative 6. So 9 minus 6, or 9 negative 6 is 3. Bring down your positive 3 from right here. The absolute value of 3 is 3. 3 times negative 2 is negative 6, positive 3. That's going to be a negative 3. Okay, let's plot our points. Let's do our vertex first. 4.5, 3, so over 1, 2, 3, 4.5, and then up 3. There's your vertex. 6, negative 3. 5, 1, over 5, positive 1. 4, 1, so over 4, and up 1, and then over 3, and down negative 3. And there's your V-shaped graph. Alright, so here we go. guys. So graphing an absolute value, any absolute value equation is going to give you out V-shaped graphs. I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.